It's head rush time, and it's time for you to show off your brain skills by tackling this scientific teaser. Now, this experiment's awesome. It shows both the strength of sand and salt. Here's the setup. I have an empty tube, and at the end, a piece of wax paper. Now, I take a broom handle and push it through. No surprises there, it goes right through the paper. But what's going to happen to the paper when I fill the tube with salt? Okay, back to our tube experiment. First up, I pushed my broom handle in and busted right through the wax paper. For the next test, my tube is filled with salt. Now, that's the only thing that's changed. You see, there's still wax paper on the bottom. So what's going to happen when I push the broom handle into the tube of salt? No matter how hard I push, I can't push the handle through. But why is that? Is it because salt crystals stick to the sides of the tube, sodium chloride molecules bond together when they're under pressure, or the salt crystals push against each other, redirecting the downward force towards the tube walls? If you got this one, you're definitely worth your salt. Yes, the hard salt crystals push against each other sideways. That deflects the downward force. So much so, the paper at the bottom receives very little original downward pressure. Engineers and architects design trusses, bracing, and other building elements to do exactly the same thing. By transferring load, or forces to desired locations, buildings stay intact and upright.